Welcome back. Today we're going to finish up exploring the mathematical exponential models. So, yesterday we talked about compounding interest. So, what happens when you compound quarterly or monthly or daily? Well, there's another type of situation that can occur. The idea of compounding continuously. Now, this leads to that equation falling apart. Because if you're compounding an infinite number of times in a year, well, you can't plug infinity into that formula. So what I ended up having to do is actually take the limit as that function. So as this function, as x approaches infinity, they took the limit and found a new number, the number e, which is 2.717 blah, blah, blah. Okay, it keeps going on forever just like pi does. Now, what this means is we have a new formula now, okay? So for continuously compounding interest, if you're compounding an infinite number of times in a year, now we have what we jokingly call the PERT equation, okay? So let's see how to use this PERT equation. So suppose you won a contest at the start of the fifth grade that deposited $3,000 into an account that pays 5% annual interest compounded continuously. How much will you have when you enter high school 4 years later or in 8 years when you graduate high school? So for the PERT equation, again, you know that's what you need because you're compounding continuously. That is what indicates you need the PERT formula. So, how much do you have? Well, you're starting with $3,000 times e to the, well, if it pays 5%, that's going to be 0.05. You still need the decimal times 4 years. All right. So again, all you're doing is plugging in those appropriate pieces. Now let's see what that looks like in the calculator. So 3,000. Now, the button you're going to be looking for is right here. Excuse me. And now that's the button you're looking for because that's going to give you e to an exponent. All right? So that's what you're looking for on the calculator. Now you need e to the 0.05 times 4. Okay, so after 4 years of continuous compounding, you're going to have $3,664.21. All right, now what about 8 years down the road? Well, you're still compounding continuously, still at that 5% rate, but this time we're going to let it go for 8 years. So what do we get? E to the 0.05 times 8. 8 years down the road, we're going to have $4,475.47. $4,475.47. And again, that's the equation you use only when you're compounding continuously, okay, an infinite number of times in a year. So actually, this is probably the easiest equation to use, okay? So I'm going to take a little bit of time because I don't think you need much more practice with that. Let's take a little bit of time to discuss where we've been in this chapter. So in the past 3 sections, okay, the past 3 days, we've talked about growth, decay, compounding interest, continuously compounding interest. Now, each of them have a slightly different equation that calls for slightly different vocabulary. So what I've done for you is I've made a nice little graphic organizer, organizing the different equations that you have with some of the vocabulary to look for. Of course, there's always more vocabulary, okay? There's always different words that could be used, some synonymous terms. But again, if you study this is going to leave you really successful on the upcoming test that you're going to have. So my goal for you is make sure you understand these formulas and this vocabulary. I'm going to take a moment now and let's go back and review these two situations from the previous notes. A culture of bacteria starts with 30 cells and grows at a rate of 16% per hour. How many bacteria will there be after 7 hours? So we're talking about growing. So that's just going to be our normal growth equation, okay? Exponential growth. So let's take a look. I'm starting with 30 cells at a 16% rate. So 16%, move that decimal place twice, is going to give you 0.16. So I'm starting with 30, 1 plus 0.16 to the t. Of course, we're talking about 7 hours. So that's what I'm going to plug in for t. So what I'm really plugging into the calculator is this. And let's see what the calculator says that is. 30 times 1.16 after 7 hours. We're talking about number of bacteria. So of course we're not going to have partial bacteria. We want a whole number. So we're going to say that is 85 bacteria. We're going to round it to the nearest whole number. And what about this next one? The Smith family is saving up for a family vacation they want to take in 5 years. They put $1,200 in the bank at an interest rate of 8.8% compounded monthly. How much money will they have by the time they want to take their trip? Compounded monthly. That's telling me I need my compounding interest formula. Okay? So that's going to be key for the test. It's making sure that you know which equation to use in which scenario. So I'm starting with $1,200. My rate is 8.8%. However, if I move that decimal 2 places over, that's going to be 0.088. Compounded monthly means compounded 12 times in a year. So 12 times, they're taking a trip in 5 years. So the key here is recognizing which equation to use, and then you have to show me plugging in the numbers to the formula, and then just use the calculator to get your answer. So starting with $1,200, 1 plus, the rate was 0.088 compounded monthly to the 12, because that's how many times it's compounded. We want to know in 5 years, how much will they have? They're going to have $1,860.26. So that's how much money they can expect to have by the time the trip comes around next or in 5 years from now. So again, just remember those basics. Going back, thinking of all 3 of these days, how to know which formulas to use, what language to be looking for, and then just plugging the values into the right location. So that is actually all for today already. All right, pretty brief and quick. So I do want you to write a summary, and probably in the summary include how you're going to study the differences to know which equation to use when. That'd be a great thing to put in the summary. And then just make sure you have all these filled out so you're ready to do your practice work in or tomorrow in class.